Titan is the largest moon of Saturn and the only known moon in the solar system with a dense atmosphere. Its atmosphere is thicker than Earth's and is composed mainly of nitrogen and methane. Titan's atmosphere is also very cold, with temperatures reaching as low as -180 degrees Celsius. NASA has been exploring Titan for decades, and in that time, scientists have made a number of important discoveries about the moon. One of the most important discoveries is that Titan has a subsurface ocean of liquid water. This makes Titan one of the most promising places in the solar system to search for life beyond Earth. In this video, we will explore some of the other important discoveries that NASA has made about Titan under its thick atmosphere. NASA scientists discovered a chemical in Titan's atmosphere that has never been seen before. Indeed, many scientists are unlikely to have heard of, let alone pronounce, cyclopropanyladine, or C3H2. According to scientists, this basic carbon-based chemical might serve as a precursor to more complicated substances that could generate or nourish potential life on Titan. C3H2 was discovered using the Atacama Large Millimeter Submillimeter Array, ALMA, a radio telescope observatory in northern Chile. While filtering through a spectrum of distinct light fingerprints acquired by the telescope, they discovered C3H2, which is composed of carbon and hydrogen. These indicated the chemical makeup of Titan's atmosphere by the energy its molecules released or absorbed. Though scientists have found C3H2 in pockets throughout the galaxy, finding it in an atmosphere was a surprise. That's because cyclopropanyladine can react easily with other molecules it comes into contact with and form different species. Astronomers have so far found C3H2 only in clouds of gas and dust that float between star systems, in other words, regions too cold and diffuse to facilitate many chemical reactions. But dense atmospheres like Titan's are hives of chemical activity. That's a major reason scientists are interested in this moon, which is the destination of NASA's forthcoming Dragonfly mission. Nixon's team was able to identify small amounts of C3H2 at Titan likely because they were looking in the upper layers of the moon's atmosphere where there are fewer other gases for C3H2 to interact with. Scientists don't yet know why cyclopropanyladine would show up in Titan's atmosphere but no other atmosphere. Titan, the biggest of Saturn's 62 moons, is a fascinating world that is, in some respects, the most comparable to Earth that we have discovered. Titan features a thick atmosphere 4 times denser than Earth's, clouds, rain, lakes and rivers, and even a subterranean ocean of salty water, unlike any other moon in the solar system. Titan's atmosphere is made mostly of nitrogen, like Earth's, with a hint of methane. When methane and nitrogen molecules break apart under the glare of the sun, their component atoms unleash a complex web of organic chemistry that has captivated scientists and thrust this moon to the top of the list of the most important targets in NASA's search for present or past life in the solar system. The chemicals that may be present on Titan's surface are similar to those that created the foundation of life on Earth. Scientists believe that circumstances on Titan might have been comparable to those today 3.8 to 2.5 billion years ago, when methane filled Earth's air instead of oxygen. Apart from benzene, the only other cyclic, or closed-loop, chemical discovered in Titan's atmosphere is cyclopropanyladine. Although C3H2 is not known to be used in modern biological reactions, closed-loop molecules like it are important because they form the backbone rings for the nucleobases of DNA, the complex chemical structure that carries life's genetic code, and RNA, another important compound for life's functions. The cyclic nature of them opens up this extra branch of chemistry that allows you to build these biologically important molecules, said Alexander Thalen, a Goddard astrobiologist who collaborated with Nixon on the discovery of C3H2. Scientists like Thalen and Nixon are using large and highly sensitive Earth-based telescopes to look for the simplest life-related carbon molecules they can find in Titan's atmosphere. Benzene was considered to be the smallest unit of complex, ringed hydrocarbon molecules found in any planetary atmosphere. But now, C3H2, with half the carbon atoms of benzene, appears to have taken its place. Nixon's team used the ALMA observatory to peer at Titan in 2016. They were surprised to find a strange chemical fingerprint, which Nixon identified as cyclopropanyladine by searching through a database of all known molecular light signatures. Nixon combed through scientific publications based on studies of data from NASA's Cassini mission, which flew past Titan 127 times between 2004 and 2017. He wanted to test if a satellite sensor that detected chemical compounds orbiting Saturn and Titan might corroborate his new finding. Cassini had discovered C3H3+, an electrically charged variant of the same molecule. Scientists are hoping to understand more about cyclopropanylidene and how it could interact with gases in Titan's atmosphere, because it is an uncommon discovery. If you enjoyed this video, please like and subscribe to our channel for more space and science. Thanks for watching.